Inside the Mission Operations Center, silence snapped into urgency. The James Webb Space Telescope, humanity's sharpest eye on the universe, was forced into emergency mode. Not for a galaxy, not for a star, but for something closer and stranger. The culprit, 3I Atlas, an interstellar comet that shouldn't even exist. Astronomers had braced for a dying chunk of ice, a faint visitor drifting quietly past the sun. Instead, Webb's first readings ignited alarms across every console. The coma was flooded with carbon dioxide levels no comet in history had ever shown. Worse, it was laced with nickel, gleaming in the spectrum without a single trace of iron. For the experts staring at the live data, the implications were chilling. This wasn't just another wanderer from the stars. It was rewriting the laws of cometary science in real time. At 2:11 GMT, the override came through. Marco Mocci's voice cut the irrigant, clipped, commanding. Ground-based telescopes had just confirmed Atlas was accelerating, its spectrum shimmering with impossible metals. There was no time for debate. Within 6 minutes, Webb's scheduled observations were abandoned. Its delicate machinery swung into position, and every eye in the control room locked onto telemetry. This override wasn't routine. Webb's schedule is a fragile ballet of orbits and fuel burns, years of planning crammed into every hour. But the scientists knew, miss this chance, and the comet would slip away forever. The command sequence went live. Webb pivoted, its instruments humming, locking onto coordinates that would soon stun the world. The first images trickled down, grainy, raw, uncalibrated, and yet unmistakable. 3I Atlas was awake. Out beyond Jupiter's orbit where most comets sleep frozen, and silent, it was already venting torrents of gas. Not water ice, as physics demands, but carbon dioxide, 8 times stronger than water, flooding into the void. Normal comets hover around a ratio of 0.7. Atlas came back with 8-to-1. The numbers weren't strange. They were impossible. As data piled in, a more disturbing secret emerged. The tail stretched faster than models could keep up, hundreds of thousands of kilometers in days. Driven by gases no one thought could be active so far from the sun. The coma was ghostly thin, almost dustless, yet pulsing with volatile signatures. And then came the shock that froze even veteran astronomers in their seats. Nickel lines flared across the spectrum, sharp and strong, but iron-nickel's eternal twin in every comet, meteorite, and planet was absent. Not faint, not hidden, gone. The ratios made no sense. Every meteorite ever studied holds 15 parts iron for every 1 part nickel. Even Amulmor's cousin, T'ai, Borisov, fit the rule. But Atlas broke it wide open, nickel outnumbering iron by more than 40-to-1. Imagine digging up a golden crown with no trace of silver or copper. That's the scale of the anomaly Webb had just delivered. At the European Southern Observatory, teams ran checks line by line. Nickel carbonyl chemistry could maybe explain it, a volatile molecule that vaporizes under starlight. But iron has no such escape hatch. It should have been there. It wasn't, and that silence in the spectrum was louder than any discovery. Then the trajectory data hit. Pan-STARRS flagged it first. Atlas wasn't coasting on gravity. It was accelerating, not smoothly, but in sharp, jittering bursts, as if some hidden mechanism was flicking on and off. Light curves added fuel to the fire. Every 7.2 hours, its brightness pulsed like a cosmic lighthouse beam, steady, mechanical, unrelenting. Comets tumble. They spin chaotic. They do not blink on schedule. The comparisons were immediate. Astronomers remembered the mystery of Oumuamua, another interstellar intruder that veered off course without engines. But this time, the signals were stronger, sharper, harder to dismiss. Atlas wasn't just a curiosity, it was a problem. Whispers spread, is this natural or engineered? Some clung to exotic chemistry, to carbon-rich nebulae where nickel ruled and iron stayed buried. Others stared at the periodic light and couldn't shake the thought of something built, not born. And history added a darker echo. Thousands of years ago, Egyptians forged beads and daggers from iron from the sky, meteorites rich in nickel. Tutankhamun's blade still gleams today with that alien fingerprint. Ancient scribes wrote of firestones falling from the heavens, omens of disaster and change. What they revered as divine gifts, we now test with but the sense of intrusion from beyond has never left us. In Cambridge, Avi Loeb wasted no time. He published a blunt question: what natural process can strip iron and leave only nickel? None. Not without intervention. His critics bristled, warning against leaping to conclusions. But the data refused to bend. A nickel-to-iron ratio off the charts. A clockwork light curve, an acceleration that didn't obey physics. Inside NASA's Planetary Defense Office, 3I Atlas was quietly flagged as a high anomaly. Not a threat not yet, but something too strange to ignore. Internal memos, usually reserved for impact risks, now tracked an enigma. Officially, the line was cautious. Extraordinary evidence required. Unofficially, even the skeptics admitted the comet didn't fit the rulebook. And so the question remains, hanging over every graph, every spectrum, every whisper of data: is 3I Atlas a cosmic fluke, a messenger from a chemistry we've never seen? Or is it the first real hint that we are not alone? For now, the truth is locked inside those readings. Carbon dioxide pouring where water should flow. Nickel blazing where iron should shine. A comet that speeds when it should coast. And blinks like a machine instead of a rock. On August 6, 2025, the James Webb Space Telescope rewrote history. What it saw in 3I Atlas may not just change how we see, it may change how we see ourselves. But here's where things spiral deeper. When astronomers extended the curve of Atlas's path, they noticed something unsettling. Its acceleration wasn't random. It wasn't just being nudged by sunlight. Every spike aligned with a faint pulse of brightness. Like a signal, like a rhythm. By the second week of monitoring, the data looked less like natural outgassing and more like a pattern repeating. Code written across millions of kilometers of space. And yet, what kind of code burns itself into a comet's tail? This wasn't just speculation. Independent observatories in Chile, Hawaii, and even amateur astronomers in South Africa saw the same flicker, the same unnatural heartbeat. Each confirmation narrowed the gap between coincidence and intent. And then came the historical parallels, whispers from the past suddenly colliding with the present. Ancient Chinese records spoke of a metal star that shone green and pulsed in the night sky. Babylonian tablets described visitors that shed light like a furnace yet moved against the heavens. Could those old records be the same type of anomaly interstellar wanderers like Atlas, misunderstood and myth? By September, the debate inside academic circles turned fierce. Some swore this was simply exotic chemistry, nothing more. Others hinted at something far more dangerous, the possibility of directed panspermia, that comets, like Atlas, might be carriers, not just of elements, but of intent. If its chemistry is engineered, could it also be designed to seed worlds? NASA's internal documents leaked just weeks later, not to the press, but to fringe researchers. Redacted, blurred, but unmistakable. A line item titled, "Non-Gravitational Accelerants Unexplained." If Atlas was accelerating from something hidden beneath its surface, what was driving it? Gases don't fire in pulses every 7 hours like an engine warming up. That's when James Webb delivered its sharpest images yet. Buried in the coma, barely perceptible, was structure, not jagged ice, not random fragmentation, but arcs. Symmetry, shapes that, to the untrained eye, looked almost mechanical. The official statement. Image artifacts. Overexposure. The whispers. Something far stranger. And here's the cliffhanger that left even the skeptics silent. Atlas wasn't just passing through. Its trajectory shifted again subtly, but deliberately curving in a way that suggested targeting. It wasn't simply grazing the solar system on a one-way trip. It was aiming toward where the models aren't precise enough to say, but one disturbing overlap keeps surfacing: Earth's orbital path. Not for collision, not yet, but for proximity. What if Atlas isn't an accident? What if it's a messenger, or worse, a probe? August 6, 2025. The James Webb Space Telescope slams into emergency mode, scrambling to capture a comet that shouldn't exist. Astronomers expected a dying ball of ice. Instead, Webb's data on 3 inches Atlas just confirmed a chemical nightmare. Its coma is flooded with carbon dioxide at levels never recorded and stir with metallic nickel without a trace of iron. The experts, calling in the override, now admit the numbers are terrifying. This isn't some typical interstellar visitor. It's breaking every rule in the book, and the deeper the data goes, the more unthinkable it gets. Is 3I loss even natural? Or is something else hurtling straight for us? The stakes only get higher from here. At 2:11 GMT, the call came through. Marco Marchi's voice clipped and urgent, cutting across the quiet of the Mission Operations Center. The numbers from ground-based telescopes had just landed. 3. Atlas was accelerating, its spectrum flashing with metals no one expected. There was no time for debate. Less than 6 minutes later, the override command sequence was uploaded to the James Webb Space Telescope. Every scheduled observation paused. For the first time in years, Webb's main science program was pushed aside by an emergency order. This wasn't a routine target of opportunity. Most twos are scheduled weeks in advance, debated by committees, weighed against the cost to other missions. Not this time. The override chain ran straight up to the project scientist's desk. Approval had to be unanimous. The risk-high Webb schedule is a ballet of orbits and fuel. Every minute, precious. One wrong maneuver, one miscalculation, and the world's most powerful observatory could lose a week of science, or worse, a critical subsystem. But the window to catch 3I Atlas was closing. The comet's trajectory was shifting by the hour. Its coma blooming with volatile gases and something else. Something metallic. Michel took the lead. His calculations run on ESA's servers pinned down the exact coordinates. The NASPEC instrument would need to slew fast, lock on, and start collecting spectra before the object slipped out of range. At 2:17 GMT, the command was live. Webb pivoted, sensors humming as ground teams watched the telemetry stream for any sign of error. In the control room, every eye tracked the data pipeline. The first packets came down raw, uncalibrated, but enough to see the core of 3 to Atlas burning bright against the background. On the shift log, the entry is short. To override 3 to Atlas, the 6th of August to 17 GMT, near spec. But behind that line is a scramble that left no margin for error. Fewer than 4 such overrides have happened since Webb launched. None for an interstellar object. The tension didn't break when the data arrived. It only sharpened. What Webb caught in those first moments would append every expectation about what a comet could be. But the chemical revelations were still to come. Carbon dioxide lines dominated the spectrum before anyone expected. At 6 astronomical units out past Jupiter, where sunlight is weak and most comets sleep, O3 Atlas was already venting gas and sheets. Tests picked up the first hints. A faint, persistent brightening, not just a flash. Then Gemini South confirmed it. Tails stretching out like a ghost limb days before the object even crossed Saturn's orbit. That's not how comets behave. In the solar system, activity kicks in closer to the sun when water ice starts to boil off. Here, the main engine was carbon dioxide, 8 times as much as water by Webb's count. The carbon dioxide to water ratio came in at 8:1. For comparison, typical comets barely reach 0.7. Even to Borisov, the last interstellar visitor, hovered around half. This is off the scale. The NASPEC instrument caught the NU3 band at 4.26 microns. Strong, broad, unmistakable. Water showed up too, but as a faint afterthought. The gas wasn't just present, it was pouring out. Production rates put carbon dioxide at 8 times the water output. Dust was almost absent, making the coma thin and the tail ghostly. But the gas was undeniable. Every cross-check, Gemini, HST, even spherics lined up. No calibration trick, no missed background. The numbers held. Bryce Boland, who spent years studying interstellar messengers, put it plainly. Every interstellar comet is a messenger from another star system. And by studying their light and color, we can begin to understand the diversity of worlds beyond our own. But this one's message is strange. A body that wakes up in the deep freeze, spewing carbon dioxide like a vent in the dark. The chemistry points to a birthplace nothing like our own. Maybe a world where water is scarce, or where carbon dioxide is the dominant ice. Or maybe a process we've never seen, one that rewrites the rulebook for how comets form and die. The tale itself grew at a pace that stunned the teams watching live. In just days, it stretched hundreds of thousands of kilometers driven by gases that shouldn't be active so far from the sun. The physics doesn't add up. The ratios don't match any known comet, not even the oddballs. And the further the teams looked, the more the numbers refused to settle down. But this isn't the strangest part. Webb spectrum had deeper secrets, signatures that would send shockwaves through every model of how comets are built. Nickel lines started showing up in the spectrum almost immediately after Webb locked onto 3II Atlas. At first, the team thought it was a calibration glitch, some stray artifact from the instrument, or maybe a cosmic ray hit. But the data held up. Nickel 1 transitions clear as day, stacking up across the ultraviolet and near-infrared. The numbers weren't subtle. At 3.8 astronomical units, the nickel production rate was already past 10⁻21 atoms per second. By the time the comet closed to 2.85 astronomical units, that number had jumped another order of magnitude. But the real shock wasn't just the presence of nickel. It was what was missing. Iron 1 lines iron were nowhere to be found. Even with the very large telescopes, UVES instrument running at a resolving power of 80,000. The spectrum was flat in every iron channel. The upper limits came back brutal. Nickel outnumbered iron by more than 40-1. In every meteorite, every comet ever studied, nickel and iron traveled together. Here, iron was a ghost. That's not normal. In solar system comets, the nickel to iron ratio hugs cosmic averages. 1 part nickel to 15 parts iron, give or take. The last interstellar visitor, Borisov, fit that rule. But 3 Atlas Brexit wide open. Imagine finding a gold ring with no trace of copper or silver. That's the scale of the anomaly. Spectroscopy teams at the European Southern Observatory and the Webb Control Center went line by line through the data. They checked for contamination, for misidentified features, for solar background. Every cross-check held. The nickel lines 3,415, 3,524, 3,525, 3,769, 3,783, 387, 3,858. Angstroms were all there stacked above the noise. The signal to noise was above 30 for the strongest features, but iron, not a blip. Not in the core, not in the coma, not in the tail. Lab data gave one possible path. Nickel carbonyl, nickel carbon monoxide for a molecule so volatile it can vaporize at 43 C. Under the right conditions, carbon monoxide-rich ices, a dash of metallic nickel, a shot of ultraviolet. Nickel carbon monoxide for can form and drift into space, breaking down under sunlight to free atomic nickel. But iron's cousin, iron carbon monoxide 5, is far less volatile. Its vapor pressure is low, its formation sluggish, its lines silent. That could explain the absence, if and only if the parent body was built in a world where nickel was favored and iron left behind. No solar system comet has ever shown this pattern. The near-infrared spectrograph team flagged the finding in their internal notes as without precedent in any volatile-rich body. The more the team stared at the numbers, the more the old models fell apart. What kind of formation environment could produce such a freakish ratio? Is this the fingerprint of chemistry we've never seen, or something more deliberate? The chemical puzzle only grew as the data poured in, but the strangers didn't stop at composition. The way 3I Atlas moved was about to raise even deeper questions. Acceleration curves started raising eyebrows before the chemical data even finished downloading. Pan-STARRS analysts tracking 3I Atlas across a network of telescopes watched as its trajectory bent away from the expected path. The numbers weren't subtle. Over a span of just 72 hours, the object's velocity increased by nearly 0.12 meters per second squared, far beyond what solar heating or gas jets could explain. That's not a rounding error. For a body 11 kilometers across, this is like seeing a cruise ship pick up speed without engines or wind. The deviations didn't follow the neat arc of gravity. Instead, each update from the ground showed a jitter, tiny sharp jumps layered on top of the main acceleration, as if something inside was flickering on and off. The Pan-STARRS team double-checked for software glitches, then called in the Minor Planet Center. All the raw astrometry held the acceleration was real, and it wasn't coming from ice alone. Light curves added another layer of confusion. Photometric data from Gemini South and TESS A revealed a periodic brightening like a lighthouse beam sweeping every 7.2 hours. That's not the slow tumble of a solid rock. The modulation was too regular, too sharp. Some tried to model it as a rotating, oddly shaped comet, but the fit was poor. Others suggested a hollow or sheet-like structure with sunlight glinting off wide, flat surfaces. Every possibility came with new problems. If the object was tumbling, its spin should be slowing as it outgassed. Instead, the period stayed locked even as the activity ramped up. Veteran observers couldn't help but recall Yumoam